Brought to you by Wikivideo Documentaries. Airbus A350XWB. The Airbus A350XWB is a family of long-range, twin-engine wide-body jet airliners developed by European aerospace manufacturer Airbus. The A350 is the first Airbus aircraft with both fuselage and wing structures made primarily of carbon fiber reinforced polymer. Its variants seat 280 to 366 passengers in typical three-class seating layouts. The A350 is positioned to succeed the A340 and to compete with the Boeing 787 and 777. The A350 was originally conceived in 2004 as a pairing of the A330's fuselage with new aerodynamics features and engines. In 2006, Airbus redesigned the aircraft in response to criticism from several major prospective customers and renamed it the A350XWB. Development costs are estimated at €11 billion. Airbus had received 854 orders for A350s from 46 customers worldwide. The prototype A350 first flew on 14 June 2013 from Toulouse, France. Type certification from the European Aviation Safety Agency was received in September 2014 and certification from the Federal Aviation Administration 2 months later, on 15 January 2015. The A350 entered service with Qatar Airways, the type's launch customer. Early designs. Airbus initially rejected Boeing's claim that the Boeing 787 Dreamliner would be a serious threat to the Airbus A330, stating that the 787 was just a reaction to the A330, and that no response was needed. When airlines urged Airbus to provide a competitor, Airbus initially proposed the A330-200 Lite, a derivative of the A330 featuring improved aerodynamics and engines similar to those on the 787. The company planned to announce this version at the 2004 Farnborough Air Show, but did not proceed. On 16 September 2004, then Airbus President and CEO Noel Forgeard confirmed the consideration of a new project during a private meeting with prospective customers. Forgeard did not give a project name, and he did not state whether it would be an entirely new design or a modification of an existing product. The airlines were not satisfied, and Airbus committed €4 billion to a new airliner design. The original version of the A350 superficially resembled the A330 due to its common fuselage cross-section and assembly. A new wing, engines, and a horizontal stabilizer to be coupled with new composite materials and production methods applied to the fuselage would make the A350 an almost all-new aircraft. On 10 December 2004, the boards of EADS and BAE Systems, then the shareholders of Airbus, gave Airbus an authorization to offer, and formally named it the A350. On 13 June 2005 at the Paris Air Show, Middle Eastern carrier Qatar Airways announced that they had placed an order for 60 A350s. In September 2006, the airline signed a Memorandum of Understanding with General Electric to launch the Gen X-1A72 engine for the aircraft. Emirates sought a more improved design and decided against ordering the initial version of the A350. On 6 October 2005, the program's industrial launch was announced with an estimated development cost of around €3.5 billion. The A350 was initially planned to be a 250 to 300 seat twin-engine wide-body aircraft derived from the existing A330's design. Under this plan, the A350 would have modified wings and new engines while sharing the A330's fuselage cross-section. As a result of a controversial design, the fuselage was to consist primarily of aluminium lithium rather than the carbon fiber reinforced polymer fuselage on the Boeing 787. The A350 would see entry in two versions. The A350-800 with a 8,800 nautical miles range, with a typical passenger capacity of 253 in a three-class configuration, and the A350-900 with 7,500 nautical miles range and a 300-seat three-class configuration. The A350 was designed to be a direct competitor to the Boeing 787-9 and 777-200. The A350 was publicly criticized by two of Airbus' largest customers, International Lease Finance Corporation and GE Capital Aviation Services. On the 28th of March 2006, ILFC President Stephen F. Udvar-Hazy urged Airbus to pursue a clean sheet design or risk losing market share to Boeing, and branded Airbus' strategy as a band-aid reaction to the 787, a sentiment echoed by GECAS President Henry Hubschmann. In April 2006, while reviewing bids for the Boeing 787 and A350, CEO of Singapore Airlines Chew Choon Seng commented that, having gone through the trouble of designing a new wing, tail, cockpit, Airbus should have gone the whole hog and designed a new fuselage. Airbus responded that they were considering A350 improvements to satisfy customer demands. Airbus then CEO Gustav Humbert stated, "Our strategy isn't driven by the needs of the next one or two campaigns, but rather by a long-term view of the market and our ability to deliver on our promises." As major airlines such as Qantas and Singapore Airlines selected the 787 over the A350, Humbert tasked an engineering team to produce new alternative designs. One such proposal, known internally as 1D, formed the basis of the A350 redesign. Redesign and launch. On the 14th of July 2006, during the Farnborough Air Show, the redesigned aircraft was designated A350XWB. Within 4 days, Singapore Airlines agreed to order 20 A350XWBs with options for another 20 A350XWBs. The proposed A350 was a new design, including a wider fuselage cross-section, allowing seating arrangements ranging from an 8-abreast low-density premium economy layout to a 10-abreast high-density seating configuration for a maximum seating capacity of 440-475 depending on variant. The A330 and previous iterations of the A350 would only be able to accommodate a maximum of 8 seats per row. The 787 is typically configured for 9 seats per row. The 777 accommodates 9 or 10 seats per row, with more than half of recent 777s being 10 abreast as the 777X will be. The A350 cabin is 12.7 centimeters wider at the eye level of a seated passenger than the 787's cabin, and 28 centimeters narrower than the Boeing 777's cabin. All A350 passenger models will have a range of at least 8,000 nautical miles. The redesigned composite fuselage provides higher cabin pressure and humidity, and lower maintenance costs. On the 1st of December 2006, the Airbus Board of Directors approved the industrial launch of the A350-800, 900, and 1000 variants. The delayed launch decision was a result of delays of the Airbus A380 and discussions on how to fund development. EADS CEO Thomas Enders stated that the A350 program was not a certainty, citing EADS/Airbus stretched resources. However, it was decided program costs are to be borne mainly from cash flow. First delivery for the A350-900 was scheduled for mid-2013, with the 800 and 1000 following on 12 and 24 months later, respectively. New technical details of the A350XWB were revealed at a press conference in December 2006. John Leahy indicated existing A350 contracts were being renegotiated due to price increases compared to the original A350s contracted. On the 4th of January 2007, Pegasus Aviation Finance Company placed the first firm order for the A350XWB with an order for 2 aircraft. The design change imposed a 2-year delay into the original timetable and increased development costs from $5.3 billion to approximately $10 billion. The total development cost for the A350 was estimated at $15 billion by Reuters. The original mid-2013 delivery date of the A350 changed, as a longer-than-anticipated development forced Airbus to delay the final assembly and first flight of the aircraft to the third quarter of 2012 and second quarter of 2013 respectively. As a result, the flight test schedule was compressed from the original 15 months to 12 months. A350 program chief Didier Everett stressed that delays only affect the A350-900 while the 800 and 1000 schedules remain unchanged. Design phase. Airbus suggested Boeing's use of composite materials for the 787 fuselage was premature, and that the new A350XWB was to feature large carbon fiber panels for the main fuselage skin. After facing criticism for maintenance costs, Airbus confirmed in early September 2007 the adoption of composite fuselage frames for the aircraft structure. The composite frames would feature aluminium strips to ensure the electrical continuity of the fuselage. Airbus will use a full mock-up fuselage to develop the wiring, a different approach from the A380, on which the wiring was all done on computers. In 2006, Airbus confirmed development of a full bleed air system on the A350, as opposed to the 787's bleedless configuration. Rolls-Royce agreed with Airbus to supply a new variant of the Trent turbofan engine for the A350XWB, named Trent XWB. In 2010, after low-speed wind tunnel tests, Airbus finalized the static thrust at sea level for all three proposed variants to the 330 range. General Electric stated it would not offer the GP7000 engine on the aircraft, and that previous contracts for the Gen X on the original A350 did not apply to the XWB. Engine alliance partner Pratt & Whitney seemed to be at odds with GE on this, having publicly stating that it was looking at an advanced derivative of the GP7000. In April 2007, Airbus former chief executive Louis Galois held direct talks with GE management over developing a Gen X variant for the A350XWB. In June 2007, Airbus Chief Operating Officer John Leahy indicated that the A350XWB would not feature the Gen X engine, saying that Airbus wanted GE to offer a more efficient version for the airliner. Since then, the largest GE engines operators, which include Emirates, US Airways, Hawaiian Airlines and ILFC, have selected the Trent XWB for their A350 orders. In May 2009, GE said that if it were to reach a deal with Airbus to offer the current 787 optimized Gen X for the A350, it would only power the 800 and 900 variants. GE believed it can offer a product that outperforms the Trent 1000 and Trent XWB, but was reluctant to support an aircraft competing directly with its GE 9115B powered 777 variants. In January 2008, French-based Thalys Group won a $2.9 billion 20-year contract to supply avionics and navigation equipment for the A350XWB, beating Honeywell and Rockwell Collins. US-based Rockwell Collins and Moog Incorporated were chosen to supply the horizontal stabilizer actuator and primary flight control actuation, respectively. The flight management system incorporated several new safety features regarding cabin ergonomics and entertainment. In 2006, Airbus signed a firm contract with BMW for development of an interior concept for the original A350. On 4 February 2010, Airbus signed a contract with Panasonic Avionics Corporation to deliver in-flight entertainment and communication systems for the Airbus A350XWB. Production. In 2008, Airbus planned to introduce new techniques and procedures to cut assembly time in half. The A350XWB production program sees extensive international collaboration and investments in new facilities. Airbus constructed 10 new factories in Western Europe and the US, with extensions carried out on 3 further sites. Among the new buildings was a £570 million composite facility in Broughton, Wales, which would be responsible for the wings. In June 2009, the National Assembly for Wales announced provision of a £28 million grant to provide a training centre, production jobs, and money toward the new production centre. Airbus manufactured the first structural component in December 2009. Production of the first fuselage barrel began in late 2010 at its production plant in Illescas, Spain. Construction of the first A350-900 center wing box was set to start in August 2010. The new composite rudder plant in China opened in early 2011. The forward fuselage of the first A350 was delivered to the factory on 29 December 2011. Final assembly of the first A350 static test model was started on 5 April 2012. Final assembly of the first prototype A350 was completed in December 2012. The production rate should rise from 3 aircraft per month in early 2015 to 5 at the end of 2015. And should ramp to 10 aircraft per month by 2018. In 2015, 17 planes should be delivered and the initial dispatch reliability is 98%. Airbus plans to increase its production rate from 10 monthly in 2018 to 13 monthly from 2019, while the Boeing 787 production will increase from 12 to 14 per month in 2019. And 6 A330 are produced monthly. Around 90 deliveries are expected in 2018, with about 15% 1000s. Testing and certification. The first Trent engine test was made on 14 June 2010. The Trent XWB's flight test program began use on the A380 development aircraft in early 2011. Ahead of engine certification in late 2011, on 2 June 2013, the Trent XWB engines were powered up on the A350 for the first time. Airbus confirmed that the flight test program would last 12 months and use 5 test aircraft. The A350's maiden flight took place on 14 June 2013, from the Toulouse-Blagnac airport. Airbus chief test pilot said, "It just seemed really happy in the air. All the things we were testing had no major issues at all. It flew for 4 hours, reaching Mach 8 at 25,000 feet after retracting the landing gear and starting a 2,500 hours flight test campaign." A350 XWB, FWWCF, MSN-2, underwent 2.5 weeks of climatic tests in the unique McKinley Climatic Laboratory at Eglin Air Force Base, Florida, in May 2014, and was subjected to multiple climatic and humidity settings from a high of 45 degrees Celsius to as low as 40 degrees Celsius. The A350 received type certification from the European Aviation Safety Agency on 30 September 2014. On 15 October 2014, ESA approved the A350-900 for ETOPS 370, allowing it to fly more than 6 hours on one engine and making it the first airliner to be approved for ETOPS beyond 180 minutes, before entry into service. Later that month, Airbus received regulatory approval for a common type rating for pilot training between the A350 XWB and A330. On 12 November 2014, the A350 received certification from the U.S. Federal Aviation Administration. Introduction and early operations. In June 2011, the A350-900 was scheduled to enter service in the first half of 2014, with the 800 to enter service in mid-2016, and the 1000 in 2017. In July 2012, Airbus delayed the 900's introduction by 3 months to the second half of 2014. The first delivery to launch customer Qatar Airways took place on the 22nd of December 2014. The first commercial flight was made on the 15th of January 2015 between Doha and Frankfurt. 1 year after introduction, the A350 fleet had accumulated 3,000 cycles and around 16,000 flight hours. Average daily usage by first customers was 11.4 hours, with flights averaging 5.2 hours, which are under the aircraft's capabilities, and reflect both short flights within the schedules of Qatar Airways and Vietnam Airlines, as well as flight crew proficiency training that is typical of early use and is accomplished on short-haul flights. Finnair was operating the A350 at very high rates, 15 flight hours per day for Beijing, 18 hours for Shanghai, and more than 20 hours for Bangkok. This may have accelerated its retirement of the Airbus A340. In-service problems had included three areas: the onboard maintenance, repair, overhaul, network needed software improvements. Airbus issued service bulletins regarding onboard equipment and removed galley inserts because of leaks. Airbus had to address spurious overheating warnings in the bleed air system by retrofitting an original connector with a gold-plated connector. Airbus targeted a 98.5% dependability by the end of 2016 and to match the mature A330 reliability by early 2019. By the end of May 2016, the in-service fleet had flown 55,200 hours over 9,400 cycles, at a 97.8% operational reliability on 3 months. The longest operated sector was Qatar Airways Adelaide-Doha at 13.8 hours for 6,120 nautical miles. 45% of flights were under 3,000 nautical miles, 16% over 5,000 nautical miles, and 39% in between. The average flight was 6.8 hours, with the longest average being 9.6 hours by TAM Airlines and the shortest being 2.1 hours by Cathay Pacific's 2.1 hours. Aircraft seat configuration ranged from 253 seats for Singapore Airlines to 348 seats for TAM Airlines, with a 30 to 46 seat business class, and a 211 to 318 seat economy class, often including a premium economy. The first A350-1000 was assembled in 2016 for a first flight on the 24th of November and entry into service planned for mid-2017. In January 2017, 2 years after introduction, 62 aircraft were in service with 10 airlines. They had accumulated 25,000 flights over 154,000 hours, with an average daily utilization of 12.5 hours, and transported 6 million passengers with a 98.7% operational reliability. Zodiac Aerospace had business class seats production difficulties in its Gainesville, Texas and Santa Maria, California factories. After a year, Cathay Pacific experienced cosmetic quality issues and upgraded or replaced the seats for the earliest cabins. In 2017, average test flights before delivery decreased to 4.1 from 12 in 2014, with an average delay down to 25 days from 68. Its reliability was 97.2% in 2015, 98.3% in 2016, and 98.8% in June 2017. Just behind its 99% target for 2017. In June 2017, after 30 months in commercial operation, 80 A350 were in service with 12 operators, the largest being Qatar Airways with 17, and 13 each at Cathay Pacific and Singapore Airlines. The fleet average block time was 7.2 hours with 53% below 3,000 nautical miles, 16% over 5,000 nautical miles, and 31% in between. LATAM Airlines had the longest average sector at 10.7 hours, and Asiana had the shortest at 3.8 hours. Singapore Airlines operated the longest leg, Singapore to San Francisco 7,340 nautical miles, and the shortest leg, Singapore to Kuala Lumpur 160 nautical miles. In 2016, 49 were delivered and the monthly rate should grow to 10 by the end of 2018. Seating varied from 253 for Singapore Airlines to 389 for Air Caraíba, with most between 280 and 320. In October 2017, Airbus was testing extended sharklets, which could offer 100 extra range and reduce fuel burn by 1.6%. The wing twist is being changed for the wider, optimized span load pressure distribution, and they will be used for the Singapore Airlines A350-900 ULR in 2018 before spreading to other variants. Iberia will be the first to get the upgraded 900 in June 2018, with a 280 tons MTOW version for a 8,200 nautical miles range with 325 passengers in 3 classes. As of February 2018, 142-900 had been delivered, with a dispatch reliability of 99.3%. Brought to you by Wikividi Documentaries. Would you like to know more?